And consequently, if we want to understand inequality today, we have to design a theory that will link the positions of societies today to their initial conditions thousands of years ago. And this is where unified growth theory is coming into play, where a single theory is linking the positions of societies today to their initial conditions very much in the distant past. So broadly speaking, in order to understand the process of development, and in order to understand the roots of inequality today, and in order to design policies that could mitigate inequality across the globe, we have to have a better understanding of the process of development in its entirety. But when you think about the process of development, one can segment this process into three fundamental phases. What I will define as the Malthusian epoch, the post-Malthusian regime, and the modern growth regime. Now, the Malthusian epoch originates at the time of the emergence of Homo sapiens in Africa nearly 300,000 years ago. And it spans literally 99.9% of human existence. This is a period of interesting dualism. Stagnation in income per capita, along with dynamism in the context of population, technology, and human adaptation. And it is this dynamism that after 300,000 year period is bringing about the takeoff from stagnation to growth. Initially into the post-Malthusian regime, and in the aftermath of the demographic transition into the modern growth regime. So largely speaking, the Malthusian epoch holds the secrets for the inequality that we see in the world today. And as I said, the Malthusian epoch is characterized by this intriguing dualism. Stagnation along with dynamism. Stagnation in living standards. Income per capita fluctuates very close to the subsistence level. Life expectancy fluctuates in a very narrow band of 25 to 40. But at the same time, we see dynamism. Dynamism in the context of technology, dynamism in the context of the size of the human population, and dynamism in the context of the adaptation of the human population to the technological environment. Now, at any point in time, technological progress is very, very slow. Population growth is very, very small, and human adaptation is insignificant. But over 300,000 year period, we're moving from stone tool technologies to steam engine technologies. We're moving from the size of the population on planet Earth in the eve of the agricultural revolution, which is about 2.5 million people, to 1 billion people in the midst of industrialization. Namely, within this Malthusian epoch of stagnation, a 400-fold increase in the size of the human population, and in addition, great adaptation, cultural and biological adaptation of the human population to the technological environment. And it is this Malthusian dynamism that after 300,000 year period is permitting the transition from stagnation to growth and generating much of the inequality, as you will see momentarily, that we observe across the globe. So one important element in the Malthusian epoch is the impact of technological progress. Technological progress over this time period is increasing income per capita temporarily. This increase in income per capita permits population to grow. Child mortality rate declines, fertility rates increases, and consequently, population is growing proportionately to the level of technology, leaving income per capita unchanged. So unlike today's world in which technological progress is converted into prosperity, this is a time period in which technological progress is converted into more people rather than into more prosperous people. This is a time period, as I said, in which technologically advanced societies such as China, or land-rich economies, such as those that existed in the Fertile Crescent, enjoy higher population density, but very similar levels of income per capita. And this will become critical in the understanding of the ultimate transition from stagnation to growth. Second, and very important, human adaptation. The Malthusian pressure is governing not only the size of the human population, it affects in addition the composition of the human population. So human traits, whether they're cultural or individuals, that are complementary to the technological environment, tautologically generate higher income. They're more rewarded. But during the Malthusian epoch, higher income is converted into higher reproductive success. And as a result of it, these traits become more and more prevalent in the population. Namely, what happens over this time period is that adaptation raises the prevalence of complementary traits to the growth process and consequently reinforce the process of development and the takeoff from stagnation to growth. So broadly speaking, if you think about the wheels of change that are propelling the journey of humanity in the course of human history, technological progress, the size of the human population, and the adaptation of the human population, they are reinforcing one another in this process. The size of the human population and the composition of the human population is affecting technological progress. More people implies more innovators, and more innovators implies greater technological progress. But in turn, greater technological progress, as I just argued, support larger amount of people, and in addition, generates human adaptation. So in the course of human history, we see these wheels of change reinforcing one another persistently. Nevertheless, there is no change in living standard for 300,000 year period, for 99.9% of human existence. But then, at a certain point, technological progress, due to this reinforcing interaction, is reaching a critical level. Namely, it reaches a level beyond which, in order to cope with this rapidly changing technological environment, individuals must start to invest in their education. But this is a time period in which parents are too poor to invest in the education of their children without economizing on other elements in their budget constraint. They cannot economize on their own consumption because their own consumption is at the subsistence level. And as a result of it, they limit the number of children that they have. So what we see over this time period is that human capital becomes essential to cope with the changing technological environment, and consequently, human capital formation triggers a fertility decline, and for the first time in human history, the growth process is no longer counterbalanced by population growth. So as I said, historically, population growth and technological progress moved in tandem, proportionately. And in the post-demographic transition period, once fertility started to decline, we see in fact that the two processes are being disentangled. And now, technological progress, as we know it today, is converted into more prosperous people rather than into more people. So if you wish, this holy triangle, technological progress, human capital formation, and the decline in population growth are propelling humanity into the modern growth regime. So to understand this better, think about the chart in front of you. Humanity starts in Africa 300,000 years ago. The size of the human population is very limited. But humans are equipped with a powerful tool, the human brain. And the human brain allows humanity to carve the environment in which they operate, namely to generate technological progress that permits more resources to be generated. But these resources are spent on more people or more adaptable people. And what we see over the course of human history is the interaction between technological progress, the size of the human population, and the composition of the human population. More people, more innovators, more technological progress, more people, more potential innovators, and more adaptable people. And in the course of human history, we see these wheels of change rotating at an ever-increasing pace. But only once the rotation reaches a critical point, a tipping point, we see the actual transition from stagnation to growth. Namely, fertility starts to decline, we see the demographic transition and the movement into the modern growth regime. Now, in order to understand it a bit better, consider a phase transition that each of you experience in your daily life, which is basically the transition from water to gas. So as you boil water in your teakettle every morning, you must have noticed that initially there is no change in the state of the water, and we see some changes in the state of the water, but no evaporation. And then once we reach a critical point, we see the transition from water to gas. This is a phase transition, a transition from the phase of liquid to the phase of gas. The same was true in the course of human history. Technological progress was heating up, but nevertheless, society remained in the agricultural stage of development due to the fact that population counterbalanced the advancement in technology. But ultimately, this rate of technological progress reached a critical point beyond which, in fact, individuals could no longer cope with this rapidly changing technological environment. Education became essential, fertility started to decline, and consequently the world moved into a different state, the state of sustained economic growth. But interestingly,